Hi, so this session is on the quadratic formula. Before we start looking on how to use this, I just want to recap on what we have covered so far when it comes to finding solutions of a quadratic equation. And we know what we mean by finding solutions. When it comes to quadratic equations, finding solutions means we are trying to find any x-intercepts that a parabola may have. So let's just recap on what we have done so far. So I've just drawn up a little chart that summarizes what we have covered so far. So with quadratic equations, when finding solutions, which means to find x-intercepts, we have been learning how to factorize. Okay, so factorizing, if possible, enables us to eventually be able to solve what we have factorized. And to factorize, we have learned a variety of methods. And we use these methods depending on what we have. For example, with the first one here, difference of perfect squares. Okay, we know we have to use this when we have something in the form of a squared minus b squared. So for example, if I had x squared minus 9, I would know for this quadratic equation, I will have to use the DOPS method. Sometimes we have a quadratic equation that is a trinomial. And I've put here simple monic trinomials. This method here doesn't really have a method. It's simply, I call it the easy method. And that is, for example, if we just expand what we have here. So if we have x squared, and then it would be plus 3x plus 2. If I had to factorize this, because it's a monic trinomial, which means the coefficient of x squared is 1, this is actually easy to factorize. Get our brackets ready. It's our first step. We have our x and x. This is all positive, so plus plus. And something times something to give us 2, that adds to 1. Well, we know that the only option is 2 times 1. And let's see if 2 plus 1 adds to 3. Yes, it does, a positive 3x. So to factorize these monic trinomials, we use what I call the easy method. And that is simply getting your brackets ready, identifying there's no number here in front of the x squared, and done. But of course, sometimes it's not that easy. And our next method we may have to use is the grouping method. Or I've also put the cross method. Some of you may prefer to use the cross method, but we have learnt the grouping method because it is more direct and we get our answer much easier. So an example when to use the grouping method, there's an example just here. And if we just take this, so if we have something like 10x squared minus x minus 2, we can see we can't use this simple method because of the 10. We can't take the 10 out as a factor because if we do, we'd end up with a fraction here. So that's where we use the grouping method. And if you remember, to use this, it's simply a times c that adds to b, okay? And we've covered that method before. So we've covered this one. Now, sometimes we have to complete the square. So we've learned how to complete the square, and we know that when we complete the square, it is when we cannot factorize what is given to us, because we can't factorize using integers. We have to use surds. So if you look at the example down here, if we have something like this, I'll just write it here. If we have x squared minus 8x plus 5, let's try the simple method. Because there's no coefficient here in front of the x squared, let's try getting our brackets ready, x, and then we've got x and times x in here, if you can see that. And now let's think of this, something times something that gives us 5 that adds to negative 8. Well, the factors of 5 that give us 5 is simply 5 times 1, or 1 times 5. And there is nothing else. Is it possible for 5 and 1 to ever get to 8 or negative 8? It's impossible. So with ones like this is where we have to complete the square. And we end up with surds as our solutions, as our x-intercepts. So factorizing, once again, enables us to find any x-intercepts. And once we have factorized whatever is given to us, we then have to solve them. And we have learned how to solve, and it's down here. So then we must solve using the null factor law. Okay, and then we finally, once we've solved it, we can see what our x-intercepts are. Now, the quadratic formula is the other option we can use instead of factorizing. So if we choose to factorize, and we have to know these methods, of course, you have to decide which method you're going to use depending on what's given to you. But if you have the option of using the quadratic formula, then the quadratic formula, all you have to do, I've just rubbed this part off, is use this formula. So we'll be going through this again properly. But this formula over here, x equals, and you got minus b, then you got plus or minus the square root of b squared minus 4ac over 2a. That's the quadratic formula. And you can actually use this formula to find x-intercepts for any quadratic equation. And the a refers to the number in front of x squared, b refers to the coefficient in front of x, or the number in front of x, and c is just the constant. You get those values, you sub them in, and you're done. And you can see how the quadratic formula has an x equals because we're finding the x-intercepts. So if you had the option of either using the quadratic formula or factorizing, so if the question didn't specify, you can see it wasn't easy to factorize, you would just go ahead and use the quadratic formula. Sub in those values and you're pretty much done. So let's learn how to actually use this effectively. So for our first example, this quadratic equation, we'll make it equal to 0, so y is 0, is actually an easy one to factorize. So I want to factorize this one first, using that simple method, and then use the quadratic formula to see if we get the same answers, the same solutions. So to factorize this, we know it's a trinomial. There's no coefficient in front of the x squared, so we just get our brackets ready. This can all equal 0. So something times something that gives me 2, that can add to 3. Well, get our x's ready. Everything is positive, and I know that 2 times 1 gives me 2, and 2 plus 1 gives me my positive 3. And we're done. We've factorized it. And now, of course, we know we have to solve this using the null factor law, and y is 0. And we know that each bracket gets a term to equal 0. So we end up with x plus 2 equals 0. We end up with x plus 1 to equal 0. Okay? So all is saying there are 2 solutions, or 2 different x-intercepts for this parabola. So to solve this, we minus 2 on both sides. So for this one, x will equal negative 2. And this one, if we minus 1 on both sides to solve the equation, x will equal negative 1. And here are our 2 solutions, when x is equal to negative 2 and x is equal to negative 1. And if we were to draw our parabola, just to recap, we will have when x is negative 1 and when x is negative 2, and our parabola will be passing through those 2 points. Okay? And that's all we've found. Now let's use the quadratic formula to see if we get the same solutions. So let's write the quadratic formula together. Now the quadratic formula is something you have to remember. And I guess the more times you use it and practice, you'll remember it. So we always have x equals. So this is the quadratic formula, x equals, and the reason why we have x equals is because we are finding the x-intercepts. It's just another way to find the x-intercepts. All right, and then we have a minus b, so minus b. Now here we have to put plus and then a minus and a square root. Now the reason why we put plus or minus is actually because in front of a square root there is actually a positive and a negative sitting there. And when it comes to drawing parabolas, it'll make more sense. But so please make sure you put a plus and a minus in front of the square root. And inside the square root, we have this b squared minus 4ac, or 4 times a times c. Don't forget, in between variables and numbers, if there's no operation, there's an invisible times. I'll just put it there now to emphasize that. So that's all on top. And underneath, so all this is sitting on top of, so make sure your fraction line goes all the way across, we have 2a, or 2 times a. And that's it. So x equals minus b, and then plus or minus the square root of b squared minus 4ac over 2a. So like I said, please make sure you practice this to remember it. Now, To understand how to use this, our a, b, and c comes from, so a is the coefficient of x squared, and b is the coefficient of the x, and c is the constant. So if you had an equation where you just say you didn't have the constant, you would say c equals 0. But we'll do a variety of examples to show this. Okay, and we can make all of this equal 0, saying that we are trying to find the x-intercept, so that's why y here is 0. Now, for our equation that we were working on, we had x squared plus 3x plus 2. That's the one we just factorized, and we got our solutions when x was negative 2 and x was negative 1. Now, we'll use the same example and use the quadratic equation. So when you do this, the next thing you should do is to state what a is. So a is the coefficient in front of x squared, a is 1. So a is equal to 1. What's our b? B is equal to a positive 3. So here, positives and negatives are very important. And c is positive 2. So always write this so it's clear to you what your a is, what your b is, and what c is. And please make sure if there was a negative, just say here you'd have a negative 3. Now, we need to substitute these into the quadratic formula above. Now, I'm going to write an important point, and that is we must substitute with, you should know this, brackets. It's extremely important, and so many students make little mistakes because they forget to do this. All right, let's start summing in. So we've got x equals minus b, so minus, and remember, substitute with brackets. So b is a positive 3, plus or minus, so plus or minus the square root of, sorry, that minus is a bit far down, we'll fix it up, b squared. So this is where it's extremely important the brackets are used in case we have a negative. So b squared, b once again is a positive 3 squared minus, and then we've got 4 times a times c. 4 times a, what's a? A is 1 times c, and c is 2. We'll just squeeze it in there. Sorry, it's a bit messy. All over 2 times a, and a is 1. So 2 times 1. Okay, now all we have to do is start simplifying. So we have x equals, now the 3 is in brackets, it's just a positive 3, no power, so we end up with just negative 3. Don't forget there's a times here, and it's really a negative 1 times 3. Plus or minus the square root of, now under the square root we've got a positive 3 squared, which is just 9, minus 4 times 1 times 2, well 4 times 1 times 2 is 8, all over 2 times 1, which is 2. I'll squeeze in our next step, and then I'll make some more room at the top. So we've got minus 3 plus or minus the square root of, 9 minus 8, that didn't have to be so big. 9 minus 8 is just 1, so we've got the square root of 1, and it's all over 2. I'll just rub off some working out from the top. And now remember, the square root of 1 is just 1. 1 is a perfect square because 1 times 1 is 1. So I'm going to continue just up here. I've made more room. All right, so we've got x equals minus 3 plus or minus the square root of 1 is 1, all over 2. Now this might be confusing you right now, and I'll show you what we mean by plus or minus. It basically means we've got two options. To go minus 3 plus 1 as our first option, and then to go minus 3 minus 1. And that's all it's saying. So now to separate this, to show it more clearly, we can have x equals minus 3, and I'm going to put plus first, so plus 1 divided by 2. Or we can have x equals minus 3. Instead of plus, we will minus 1 and divided by 2. Now, please make sure, if you were to put this in your calculator and you went minus 3 plus 1 and you push the division sign, so divided by 2, please be careful because the calculator may do this. It may go 1 divided by 2 first and then minus 3, and that is incorrect. So if you do put it in your calculator, please make sure you go minus 3 plus 1, then equals, and then divide by 2. Or put in brackets and then divide by 2. So I'm going to put brackets to emphasize you must calculate what's on top first and then divide by 2. Now, minus 3 plus 1 is just minus 2 divided by 2, or our other solution, x will equal minus 3 minus 1 is minus 4 divided by 2. And finally, if we simplify this, minus 2 divided by 2 is minus 1, and minus 4 divided by 2 is minus 2. And they are our two solutions, our two x-intercepts. And if you look back at your notes, you will notice that they are exactly the same as what we found before. When we factorize this using that quick method, we got the same solutions, x equals negative 2 and x equals negative 1. So the quadratic formula is an option for you. And using that formula, you don't have to actually factorize. You just substitute in the values of a, b, and c, and you're pretty much done. So let's try question 2. Now, here's the equation. We've got minus 3x squared minus 6x minus 1. It's a trinomial, and we are asked to use the quadratic formula. So I've got the quadratic formula here. I just wrote it up. And now let's identify what a is. A is negative 3. B is, it's negative 6. And C is a negative 1. Oops, C equals negative 1. And now all I have to do is substitute these into the quadratic formula, but please make sure, especially in this case, you substitute with brackets because we have negatives. All right, so we have x equals minus b, and b is minus 6, plus or minus the square root of b squared, so bracket b squared, and b is minus 6 again, squared, and you can see why here it's so important. Minus 4 times a times c. So minus 4 times, what's a? A is minus 3 times c, and it's minus 1. Sorry that it's squished in there, but you're writing this down as well, so you understand your notes. So that's 4 times minus 3 times minus 1. And it's all over 2 times a, and 2 times a is negative 3. Okay, now let's just simplify this, and I'll start right at the end to make more room. Now you notice that here we've got a negative and a negative together. That will give us a positive 6, so we end up with 6 plus or minus, I'll get the square root ready. Now you can see here how important it is. Minus 6 squared, because that minus is in the brackets, we are saying minus 6 times minus 6, which equals a positive 36. If that negative wasn't in the brackets, for example, if you put this in your calculator, minus 6 squared, your calculator will just do this. 6 times 6 is 36, and because there's one negative and it's not being squared, your answer will be negative 36. Okay, that's why it's so important to substitute with brackets, because these brackets are saying that negative is also being squared. And it's saying 2 negatives, and 2 negatives gives us a positive 36. So 36. Minus 4 times negative 3 times negative 1. All right, so I'll leave it in brackets for now. Still, 4 times negative 3 is negative 12, and negative 12 times negative 1 is positive 12. So just be careful. Okay, remember again, 4 times, that negative is still outside the brackets. So in the brackets, I've got a 4 times a negative 3, which is negative 12. And a negative 12 times a negative 1 gives us a positive 12. Oop, and it's all over 2 times negative 3, which is negative 6. And I'll just make some more room. Oop, so just continuing. Now, in here, we've got 36 minus a 12. We end up with, because a negative times a positive 12 is a negative 12. 36 minus 12 is 24. So we end up with x equals 6 plus or minus the square root of 36 minus 12 is 24. All over negative 6. Now at this stage, you'll notice that the square root of 24 is not a perfect square, it's a surd. So with these solutions, our x-intercepts will be irrational numbers. Now, if you remember how to simplify a third, the square root of 24 can be simplified to 2 square root of 6. If you remember how to simplify thirds, a perfect square that's a factor of 24, for example, 4 times 6, and then the square root of 4 is 2, and 6 stays under the square root. So your textbook may have an answer where it's left in exact form. If you remember, exact form means when you don't round off your answer. For example, if I had the square root of 2, and I can say, just say I worked out something, I got this. I can say equals the square root of 2. That's exact, okay? Because we know the square root of 2 is irrational. It never ends. Its decimal never ends. And if you want to find out the approximate number, that's where you say, all right, if I'm going to round it off, the square root of 2 is approximately 1.41 to 2 decimal places. So you just put the square root of 2 on your calculator. You'll notice it goes on like 4, it's got 0.41, 42, 13, 5, 6, 2, and so on. And that's where we have to round it off. And that's an approximate answer. So when working with the quadratic formula, and you're asked to find the solutions, always read the question carefully. If it says to leave it in exact form, okay, that means you leave it with the square root with the thirds. So for example, this is pretty much done, okay, but you should be able to simplify the square root of 24 using your third skills. If the question asks you to find the approximate solutions, that's where you have to put it in your calculator and find approximate solutions, and that's where you round off. So for this example, we will do both, okay, and we will use our third skills. So it's okay if you have forgotten this. If you couldn't continue and you had this, that's fantastic. And I guess you could do this. You can end up saying, well, x equals, for an exact answer, 6. But we've got plus first, plus the square root of 24 over negative 6. Or we can have x equals 6 minus the square root of 24 over a negative 6. And if you had that as your exact solution, I'll be happy with that. But try and remember how to simplify the square root of 24. It's not hard at all. And now let's see what the approximate solution is. So all you're going to do now is put this in your calculator, and remember, you do 6 plus the square root of 24 on this side, and then divide it by negative 6. And here, 6 minus the square root of 24, and then divide it by negative 6. So just to emphasize, these are exact answers or exact solutions, okay? And you can stop there if the question said that. And for an approximate solution, so of course, if you're trying to draw the parabola, you have to then put this in your calculator to see roughly where the decimal is. So if you put it in your calculator, you should have ended up with x is approximately equal to, for this one, 6 plus the square root of 24 equals, and then divided by negative 6 is negative, to 2 decimal places, 1.82. Or you could have had x is approximately equal to, on this side, negative 0.18, if you put that in your calculator. 0.18. And they're both negative. So if you were to draw these parabolas, okay, if you were to draw this parabola, I'll just make some more room at the top. So to quickly just have an understanding of what's happening, if our first approximate solution, if x is negative 1.82, so 1.82 will be approximately here, close to negative 2, or x is negative 0.18. So 0.18 is way less than 0.5, so it'll be about here, just say. And then your parabola will be passing through roughly like that, okay? And that's what we have found. So just remember, when you do end up with thirds, try and simplify your thirds. If you can't, it's okay. And then if the question asks you to find an approximate answer, or of course to draw it, that's what you have to do. Put it into your calculator. Please make sure you're careful when doing that. And instead of equal signs, we've got the squiggly equal sign saying approximately these are our x-intercepts. So to quickly summarize this session, to find solutions, and we know solutions means x-intercepts, okay, for a quadratic equation, we know the types of solutions we can have. The methods you can use, well, the two avenues, you can either factorize, and when it comes to factorizing, you know all of those other methods depending on what type of equation you have, or the other option is to use the quadratic formula. Okay, and that is something you have to memorize, so please memorize the quadratic formula. And the next important point is always substitute with brackets, so make sure you've got that down somewhere. You can have your answer as an exact solution. If you have a surd, that's exact. An approximate is when you round off, and the question may ask you to round off to 1 decimal place or 2. If they don't specify, usually you just round off to 2 decimal places, okay? And you might have, for example, 1.41, okay? And that's approximately, and that's exact with the equal sign. So hopefully that wasn't too difficult. All you have to do now is just keep practicing, and the more you practice, the better you'll become. Thank you.